Marites is planning to extend the sides of her square garden by 4 meters so that its area becomes 169 square meters. What is the original measure of the sides of the square garden? So to do that, we have to assign specific values to some variables. And let us suppose x be the measure of the original square garden. And x plus 4 be the extended measure because it was mentioned that Marites is planning to extend it by 4 meters on all sides of the square garden. Now, it is also asked to find the original measure of the sides of the square gardens. Therefore, we have to solve for the value of x. And to do that, we have to use the formula for the area of a square. The area of a square is equal to the sides squared. It is also mentioned in the problem that the extended measure that Marites wants is equal to 169 square meters. So we substitute it here. And we are talking about the extended square gardens. And we have already assigned it to variable x increased by 4. So our side of the extended garden is equal to x plus 4, and then square it. And to simplify this equation, we only have to take the root of both sides, so we can cancel out the exponent and the radical sign. So only x plus 4 would remain. And then on the left side, the square root of 169 is positive 13. To simplify this further, we have to use the addition property of equality and add negative 4 to both sides of the equation and then simplify. Negative 4 plus 13 is equal to positive 9 equals positive 4 plus negative 4 is equal to 0. So only the variable x would remain. Therefore, x is equal to 9. And we should go back to our representations that x, the variable x, is assigned as the measure of the original garden, the measure of the sides of the original garden. Therefore, we may conclude that the measure of the sides of the original square garden is equal to 9 meters. What is the original area of the garden? In the previous example, we have already computed that the measure of the sides of the original measure of the sides of the square garden is equal to 9 meters. Now we are asked about the original area of the garden, and to solve for its area, that would only be equal to x squared because x is the measure of the side. So area, let us substitute the value of x, which is 9, take its square, and then simplify. 9 squared is equal to 9 times 9, and that is 81. Therefore, the original area of that square garden is equal to 81 square meters. The velocity v measured in MPS of an object can be measured in terms of its mass m measured in kilograms and kinetic energy E sub k measured in joules, or in symbols that would be v equals the square root of 2 times E sub k divided by m. Question: what is the kinetic energy of a bowling ball with a mass of 3 kilograms that is traveling at 6 meters per second? So to do that, we only have to substitute the given values to our equation. So the given values are the mass which is 3 kilograms, the velocity, which is 6 mps, and we are asked to solve for the kinetic energy, which is represented as E sub k. Using our formula, V equals the square root of 2 E sub k over m. We only have to substitute the given values and then solve for the missing variable. So the velocity is 6 mps equals 2 E sub k. We don't have any value for E sub k, so this will remain as it is. And then the mass is given as 3 kilograms. To eliminate the radical sign, we have to take the square of both sides and then simplify. 6 squared is equal to 36 equals, we will now cancel the radical sign and the exponent. So this would be 2 E sub k divided by 3. To further simplify this equation, we have to multiply 3 to both sides of the equation. 3 times 36 is equal to 108 equals, we may now cancel this out, so only the numerator 2 times E sub k would remain. And then to solve for the value of the kinetic energy E sub k, we have to multiply both sides of the equation by 1/2 and cancel this out. E sub k would remain, and then take the 1/2 of 108, and that is 54. And 54 is our kinetic energy, 54 joules.